Hi, this is Billy Hubbard from NEI. For the past few years, we've been working to develop a commercial STEM EBIC system, and we're very happy to announce that this system will be available for purchase in 2022. Our system will include a custom TEM biasing holder, which has been optimized for acquiring EBIC in the TEM, and this was developed with Hummingbird Scientific. With this holder, you can also perform just general heating and biasing experiments, whether or not you're acquiring EBIC at the same time. We will, of course, have very sensitive low noise current amplification for our EBIC signals. And with this system, you'll be able to generate images with both standard EBIC contrast and also SEEBIC contrast, both of which I'll talk about in just a minute. With this system, you can acquire two separate EBIC signals simultaneously, which will allow you to independently probe different regions of your device, which can often lead to some pretty interesting contrast. And this can also help distinguish between the two EBIC mode in situations where both modes are present. We've developed a number of different substrates for looking at EBIC on electron transparent samples. So whether you're interested in heating and biasing in situ experiments, or you're looking at nanomaterials, or you're interested in fib cross sections of commercial components, we have a device architecture that should work well for your application. If you're familiar with the term EBIC, you're probably thinking of what we refer to as the standard EBIC mode. And this is the separation of beam-induced electron hole pairs in a local electric field. This process has relatively large yield, something on the order of 1 to 100 relative to the incident beam current, and it's been used since the 1960s to map electric fields and to measure carrier properties in devices. It's primarily performed in the SEM, but occasionally it's been extended to STEM imaging as well. A few years ago, we demonstrated an entirely new mode of EBIC called SEEBIC, or secondary electron emission EBIC. SEEBIC measures the holes left behind when secondary electrons are ejected from the sample by the incident beam. This process has much smaller gain than standard EBIC, something like 1 to 10% of the incident beam current, which is one of the main reasons why it was only demonstrated just a few years ago. For example, in the data below, the largest SEEBIC currents we see are on the order of just a few picoamps. And so this is about 1,000 times smaller than the currents that you're typically measuring when you're performing EBIC in the SEM. SEEBIC provides a very quantitative measure of the secondary electrons that leave your sample, which also allows you to do some metrology, like measuring the work function, for example. SEEBIC has been demonstrated at very high resolution, approaching atomic length scales. And perhaps the most useful application we found for SEEBIC is the ability to map electrical conductivity at high resolution. So bringing this all together, here's just one example of the types of experiments that you can do with this system. So here we're looking at a resistive memory device. And if you look in the bottom row of EBIC images, you can see that as we increase the bias between the electrodes, between the first two frames, we see a conducting filament growing from the lower electrode towards the upper. And between the second and third, we can see a large electric field forming as that conducting filament approaches the upper electrode. Now notice that there is no corresponding contrast in any of these ADF STEM images. And this is just one example of how STEM EBIC provides really rich detail about the electronic structure that you really just can't get through any other means with normal STEM imaging. If you're interested in some of the recent developments in STEM EBIC over the past few years, I highly recommend taking a look at these publications listed here. And I'd also like to announce that we've launched a YouTube channel where we're going to talk about a few of the things that we touched on in this introductory video, but didn't have time to go into in greater detail. If you have any questions about our STEM EBIC system or about EBIC in general, please don't hesitate to send us an email. We can't wait to hear from you.